For question 6, it is a composite question. In part A, we are testing you on your knowledge on kinetic model of matter. And then for part B, I'm testing you on Newton's third law. So for your question 6, it is the standard question asking you how would the pressure change when I trigger some changes here. So I know that you guys are not good when it is about air being pumped into a fixed container, because I'm still getting answer whereby you say when air is being pumped in, the volume of air will actually increase. This is very wrong, because the volume of air depends on the amount of space within this rocket. And this rocket is, although it's made of plastic, it is not like a balloon, it can stretch. So even if you pump in 1,000 kilogram of air, it is going to occupy this fixed volume of air. The volume of air is limited, okay, by the space of your container. So if your container is not stretchable, it is not elastic, that volume is going to be fixed. Yeah, this volume is going to be fixed. You cannot change it. When you pump air in, what you are doing is that you are bringing in more number of air molecules into that particular fixed volume. So if you are pumping in air, it is the mass of air that is increasing. But when we want to talk about this, we want to say that the volume stays constant and the mass increases, or the number of molecule increases. We want to say it in one sentence. So because of that, in my notes, I have already highlighted that there are only 4 things that you are going to comment on when it is kinematic model of matter. Refer to my notes. Okay, one of it is the number of air molecule per unit volume. Just follow. Okay, so in this case, some of you also make a error. You replace this word with area. We are dealing with 3-dimensional object. So when you write the term number of air molecule, it is per unit volume, not area. Okay, this is wrong. Okay, so of course, the volume is fixed, the number of molecule is rising, so the whole ratio is getting larger. You notice that in my answer over here, I have not commented on collision force, because collision force only change when there is a temperature change. The molecule can only knock onto the wall with a higher force if you supply energy. And once you supply energy, the temperature will rise. In this case, there is no mention that the temperature rises. So in this case, you don't need to talk about collision force. Just focus on the collision frequency. And many of you are still making the mistake. This collision frequency, right, is not in between molecule. In between molecule, yeah, they collide. But when we want to talk about pressure in the bottle, we are talking about this molecule knocking onto the wall and hence creating the pressure. As such, this collision frequency, it is between the air molecule and the wall, not between the molecule themselves. Okay, it is a very basic error that you shouldn't be making. Okay, last but not least, once you talk about collision force, and collision force is not changing here. Once you finish talking about collision frequency, you can directly proceed to quoting the formula that actually governs pressure. And in this case, P equals to F over A, you can write this just as how I'm presenting to you now. And of course, because collision frequency increases, your F will rise, because now you're colliding like 1,000 times per second. Well, correct or not? So obviously the average force will increase. Since the wall surface area, this A refers to the wall surface area, is the same. So as a result, your pressure increase. Just these 3 points will get you the 3 mark. So if you are not getting it, it only means one thing. You are not preparing yourself. You are not reading the notes. You are not memorizing it, or that you are using your own words. Can you please stop doing that? Yeah. I have taught you and gave you the notes so that you can use scientific accurate term. You get what I mean? A physics exam is to check how ready you are to communicate with fellow scientists scientific terms that describe accurately what is happening. Yeah, so that is why. Okay, for part B, it is a challenging question because it tests you on Newton's third law. Newton's third law, actually nothing to be afraid. Once you see action-reaction pair, right, it is very straightforward. What is action-reaction pair? A force, right, consists of two parts. A force is, it must be exerted by something, and it must be acting on another body. So for example, you can imagine a body like that, correct? I can exert a force, right? Danny, right? So this force, I can call it, okay, this force is exerted by Danny on an object, this called a box, okay, B, on B. Okay or not? This is Danny on B. Yeah, you can also draw it this way. Right? You can also draw it this way. It's being pulled by me, right? So this one is when it is being pulled. This one is when it is being pushed by me, right? But it is still a force by Danny on box B, right? So you see, the direction doesn't matter. It is about your understanding. This force is exerted by Danny on box. This force, it is being pulled, right? It is also by Danny on B. Okay, it is the same nature, right? What is this nature? Both of these forces are acting on the box. You get what I mean? So these two force is of the same nature. Both of them are acting on the box. So if now I want to write, okay, tell me the reaction force of this guy. Well, it is very, very, very straightforward. Well, I just need to change several things. Well, the reaction force must be the force exerted by the box on Danny. This one also, the force by the box on Danny. So in short form, how do I write this? This is FDB. This is FBD. This is FDB. This is FBD. So as long as I am able to identify the two objects, one being the one exerting the force, the other being acted on, as long as I can identify this, well, I can then swap them around, right? I can swap, okay, box will appear here, Danny will appear here. Done. I'm done identifying the reaction force. Yeah. It's just this simple. So let's look at this, how to apply it to this. Well, they want the reaction force, action-reaction, so they want the reaction force of this particular upward force. And this force is acting on the rocket. Okay, they didn't tell you it is by what, but you can guess, right? The rocket is going to fly up. So this rocket is going to fly up because the water and the air or whatever is going to be pushed down. So this thing is going up, right? The only way that this rocket can go up is because the air is pushing it up. So I can then assume very quickly that, okay, this force acting on the rocket, maybe it is by the air or by the water or by both. I don't care, right? I just need a name, that's all. So how do I describe this? Whenever I'm describing a force is a vector. So a vector has two parts. So to describe this particular force, I must describe two things. Magnitude, I must describe its direction. Do I know the original direction? Yeah, I know. No? Upward here. Right? So very simple. To answer this is like giveaway. Yeah, I just need to say, okay, the reaction force is, right? Very simple, straightforward English, is a downward force, because reaction force will be opposite in direction, so a downward force, right? I Q here, so I tick, right? A downward force that is of the same magnitude, right? So I quickly clear this one first because this is like the easiest way to score this mark, right? A downward force that is of the same magnitude. So finish. Wow, then a lot of you will try to continue a comma and then dot dot dot, you know. Please, 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 please don't do that, okay? Make it straightforward, short sentences. So before I go into this, let me move this whole chunk of stuff first. Okay, let me move it down. Okay, move it down, yeah, so that it is not blocking me. Okay, so this will be my first mark. Okay, second, yeah, easy. I haven't talked about the name, right? So I will say this reaction force is called, you see, simple English. You don't need to link the two sentences together, just separate them. Okay, this reaction force is called, now I make use of this, right? This thing, if you are from my class, you would have remember me saying, oh, reaction force of FAB is FBA. So just change these two. Okay, so in this case, what is my A, what is my B? Well, it is on the rocket by the air, right? So in my mind, I will change this to make a guess before I tell you the answer. Make a guess in your mind. I give you 5 seconds, you make a guess, okay? 5, 3, 1, okay? Okay, the reaction force is called what? Well, it's called force acting on rocket, right? So now I cannot acting on rocket already. I must swap with this guy, right? So I just use the same lingo lah. Acting on the air. Then what? By air, I cannot by air already. I must swap with this, right? Or by rocket. By rocket. Done already. Correct or not? Because the question only want me state the body on which it act on. I write already what? State the body or it act on air lor. Air is a body. Yeah, a body of air what? Correct? Or you want to talk about the water. Water also can. We accept both. Yeah. So this is how you tackle Newton's third law kind of question. You just swap the two roles, right? The role being rocket. First, it is acting on the rocket. Then after that, by the air, right? So you swap the two lor. Yeah, so it become the reaction force, become the force acting on the air by the rocket. Yeah, in fact, some of you are at this point are thinking, what are you talking about? What do you mean by the force acting on the air by the rocket? You mean the rocket push the air down? If you think about it, it is true. You see, you got this rocket, right? Correct or not? Then if you imagine if you are standing here, you are floating here, you are a mosquito flying here. Okay? And then the rocket is going up. What will you do? You will feel that the air will push you down, right? Why? Because as this rocket is going up, it is pushing a very huge amount of air down. That's why if you are a mosquito here, you like that drop to the ground, right? You will be pushed to the ground, right? So why the air got pushed down? Because the rocket is pushing the air down. Yeah. So that's why down here, if you were to draw the free body diagram, right? You have two free body diagram. You have this air. The air will experience this force. The force by the rocket on the air. Then if you want to draw the free body diagram on the rocket, the rocket will also experience an upward force. This is the force by the air on the rocket. And in fact, that is what a propulsion system is, right? You ignite the fuel. When you ignite the fuel will burn, right? It will heat up and then the air will expand. Correct or not? When you have fuel, right? Then you introduce a spark. Then what will happen? Combustion will happen, and then this fuel will vaporize. A chemical reaction will occur. It will turn into O2, CO2, a lot of different gases, and then it will expand. When this thing expand, but the fuel tank is of a fixed volume. So how? The pressure go up, what? Then what happened? Then you introduce an outlet, so all this air and combustion, the air produced by the combustion will come out. So this will become like the rocket is pushing this air down. So as a result, the air push the rocket up. So that's how a propulsion system works. You have to push something out, yeah, in order to go forward. Okay, if you forget, right, go and revisit your notes on Newton third law. You will see that there's a squid, yeah, and then I use the example of a squid to demonstrate to you how Newton third law enabled the squid to actually go forward, and of course the squid will push a lot of water out. Yeah, that is Newton third law also. Yeah, and just for revision's sake, reaction force, right, action reaction pair, right, will never appear on the same free body diagram. So for example, if I only want to do the rocket free body diagram, right, this part over here will not appear because this reaction force is acting on the air. It will not appear in the free body diagram of the rocket. Okay, so the classic question about, oh, I have an object resting on a table, the object has a weight of, I don't know, 200 Newton, then of course my because the object is stationary, I would also have a normal contact force that is 200 Newton. Then the question will ask you, oh, these two are same magnitude, different, opposite in direction, are they action reaction pair? No, they are not. They are not action reaction pair. Normal contact force is by the ground on the box. Yeah, the weight is by earth on the box. Can you see? Both of these is acting on the same object. There is no FAB, FBA over here. They are the same. Okay, so they cannot be action reaction pair. So a rule of thumb is that if it is just a single free body diagram, right, there's no way that the forces appearing in it are action reaction pair. Okay, so that's another rule of thumb that you should have. By the way, Newton third law come out many years. 2020 it came out, 2019 it came out, 2018 it came out. Cambridge know that students are not confident about Newton third law. It will come out in 2021. Okay, so do